Hi guys, welcome back to the channel. For this video, we actually do have a very good reason that it took us longer to get it out. Basically, in order to get the van in and out of the garage, it could not be on these tires. So it's been on rims inside for the past few months, and now that it's finally out for good, we can raise and lower the roof again and make an entire video on our PopTop design, how we landed on that design, how we built it, and we're really excited to just be really pressing the button over and over again and watching the roof go up and down. So yeah, let's get into it.
So our design uses 4 of these linear actuators in each of the corners. You can see the actual rod part up here, and then the shaft and motor are down there. Along with this, in each of the corners are there's 8 of these gas struts, so 2 in each corner, and we'll go into this later, but these are intended to provide all of the lateral stability to the top. So one of the nice things about our design is that it uses absolutely no latches, so going up and down is really easy. Basically, all you have to do is you first have this kill switch here. As a safety, this switch does absolutely nothing if this kill switch is off. And then once you activate the kill switch, now this is live and you can just use this one switch to raise and lower the top. No need to adjust any latches or anything. It's all ready to go. So this design has a lot of lift. The actuators are providing about 36 inches of lift. And you can see here, we have about 45 inches from the edge of the box to the roof. Plenty of head space for the bed when that's eventually done. This design also has a ton of stability, which I'll show you guys. So first off, let's just shake the car here. You can see there's absolutely no movement of the roof separate of the body. Everything moves as one piece. So here's a shot of us actually shaking it. Spoiler alert, Cam is currently on the counter, and she can still stand in there. But as you can see, absolutely no movement of the top. The entire van, the entire van moves, so everything's really solid. You can also see how tall this is. So I'm actually standing up on something. For reference, I am 6'5", and I can literally not touch the top with my hands up. So we have about 8.5, 9 feet of standing height in here with the top up, which is extremely high, and gives us a ton of space and really just opens up our interior and allows us to kind of have way more interior space on a similar footprint vehicle. In terms of raising speed, it takes about 20 to 30 seconds to go up and down. The speed is based on the strength of the actuators and the gearing, so the slower the speed, the stronger the actuators, but we kind of chose a happy medium of, I think they're about 200, 250 pound actuators in each corner. Our roof weighs, only 250 pounds total. So this is plenty of strength. It allows us to not have to worry about, if there's snow on the roof, we can be on the roof when it's up. It's just really strong and a really robust system. One of the major benefits of our design is that it's extremely lightweight in terms of all of the hardware required to lift the roof. So you're literally looking at it right here. We just have 2 gas struts a corner and then a linear actuator, which weighs basically nothing. This is one of the things we're going to get into. We're going to have another video coming out next week. We promise. We already filmed it. It's all ready to go. It's done. It's happening, I swear. So in that video, we'll kind of deep dive into like a comparison between all the different PopTop designs. But of about all of them, I think this one is the lightest in terms of the extra hardware required to actually lift the roof, at least for an electric design. So yeah, really not a lot of weight, and for how strong it is, I'm really happy with how that turned out. And then on top of that, there really is minimal things inside the van taking up space. From this side all the way around is where our bed is going to be. And there's absolutely no hardware inside of here. All the hardware is outside. It's a little confusing right now because we don't have our canvas on. The canvas is ready to go and ready to be installed. We're just kind of waiting on it for a couple random reasons. So basically when the canvas is in, all of this hardware is going to be on the outside of the canvas. However, when the top is down, all of this hardware is actually on the inside of the top. So the nice thing about that is you kind of have the best of both worlds. You don't have all this stuff taking up room inside, but at the same time, it's not exposed to the elements while driving or when the top is not up because it's on the outside.
Inside.
Because it's on the inside of the vehicle.
So before we landed on this design, we were actually totally committed and fully built a totally different PopTop design. It was a scissor mechanism, and it was based on CCV's design, Colorado Camper Van's PopTop. We actually just ended up improving it a lot. We lowered the overall weight substantially, we increased the rigidity, and we synchronized the actuators, and literally everything was built. Every bit of machinery had been bought, every little part down from like the smallest of things was like categorized, ready to go.
So we're about ready to do our mock assembly of the PopTop. Before we actually built it on the vehicle, we just wanted to try doing it on the table just to make sure everything's working as expected. So wanted to take some time to kind of go through the different components of that. So first up, we have the hardware. We got a lot of shoulder bolts here. Essentially what these will do is act as pivots for the various bars. So for example, this is one of the long crossbars that will go side to side in the van. And this is a press fit sleeve bearing I installed in the aluminum. And the shoulder bolt will essentially fit in like that and then be able to pivot the bars. So got a couple other different sizes of shoulder bolts for various things. We got these thrust bearings, which will just act as a lubricated washer just to make things slide a little bit easier and give us some extra spacing where we need it. Just some various bolts, and then this is for mounting into the unistrut channel. These basically just kind of sit inside the slot and give you a nut to tighten into. And then these are the parts for the top bars, essentially. So this is where the top pivot bar will go into. These were all laser cut steel and then TIG welded and painted by us. And then for mounting the linear actuators, we have two actuators here, which are both 24-inch actuators. And you'll see more when it's assembled, but that'll essentially get mounted in the vertical position. But for mounting the rear of the actuator, I have these brackets we made, which will essentially bolt into the unistrut up like that, and then give us a point to mount the back of the actuator. These are the bars for actually raising and lowering. So you can see what I was talking about earlier, how essentially this piece right here, you have the shoulder bolt that'll go in there, and then this piece will pivot along that point. And then these bars are what are actually, raising and lowering with the top goes up and down. We also have press fit bearings on there as well. And then over on this side, did something a little bit fancy for this bar. So the top of this is what actually will slide inside the actuator. So we got some laser cut tubing with a slot in it, and then fit in this laser cut part into there. So this part will essentially slide inside the actuator slide inside the unistrut channel, and then this is where the actuator mounts to. So yeah, that's kind of all of the parts. We have 3 more of these kind of bar assemblies. We're gonna go ahead and just kind of fit everything together and see how it goes.
And we ended up doing a full mock-up on the table, put the roof panel on, and then had this moment of, oh wow, this isn't gonna work. And we had actually been considering doing this design for a while. We just didn't have a good reason to fully scrap an already made design, which we'd already put hours into designing and building. So it was a really hard pill to swallow, but once we finally kind of had that realization that the scissor mechanism wasn't going to work, it freed us up and allowed us to get this done. And I'm honestly really happy that that's what happened. In the moment, not so much, but here we are, and the PopTop is really elegant and better in pretty much every way. Even though we had already improved the scissor mechanism so much, this is even better than that was.
So the first big challenge of this design was how we actually passed the actuators from inside the box all the way to the outside of the box. And we came out with this really cool design. And essentially how this works is you have this part right here, which is a part we actually 3D printed. This profile is the exact same as the top of the actuator. So the top of the actuator gets captured in here and actually bolts to these holes you can see here. And then these are just mounting it to the box itself. So these are special closed end blind rivets. You can see at the bottom there, it's sealed so it doesn't let water in. And then we added a stainless washer and a little bit of silicone around the edge adhesive, RTV adhesive. So how this works is the rod is essentially coming through that part, and then on top of that we have this extra water seal. So if we didn't have this, the water could have just kind of pooled in here and pooled on the top of the actuator, but this gives another level of sealing to even further protect the actuator. Because this is technically outside of the van and it does get rained on when the top is up. It still would be covered, but it is able to get wet, so we wanted to be extra cautious there. The other problem was, we didn't plan on doing this right away. This wasn't our initial design. If we had planned this from the very beginning, it would have been way easier. We wouldn't have had to do any of this extra work. We kind of had to work with what we have, and we'll relay some footage of it, but getting that hole to be where it was and the shape it was very hard. We ended up kind of coming up with a clever way to do that, which we will show in the video here. So what we want is we want the actuator kind of mounted like this in the corner, and then we wanted to drill a hole exactly where we needed the actuator to pass through this panel. Basically how we did that is I first 3D printed this little part here with the hole exactly where we wanted. And the intention is this part goes against the corner here, and then gave us a precise hole where we could drill up from the bottom up to the top. Then on the top, what I did is 3D print this little piece, which has this pin to locate the hole, and then this is the shape of the actuator body. So then this would go in that little tiny hole we just drilled from the bottom. And then this little outline here would go right over that, and then take that part out. And then this is what we actually used as our routing template. So we taped this on and then traced that in the hole. And then we essentially got a precise hole. So now the actuator can fit right up through there to the top. So I apologize, this is a little hard to see, but this is how the bottom of the actuator mounts. So I welded up these little brackets here, and they basically were like, we had some really tight constraints. As you can see, this cabinet is like right against the bottom of this. So we welded up these little brackets that then bolt onto this very large piece of aluminum angle that has a ton of glue surface. And that's what allows it to go up and down. On the top, things are a little more complicated. So what you can see is the rod goes up and then ends this metal bracket that we have glued into the corner. Again, this is a ton of glue surface here. So you have this entire piece here, this entire piece, and the top. I forget the exact numbers on it, but I'll throw up a number of the estimated strength of the glue that just this one bracket has.
5.
5. It's exactly 5.
5 strength.
Ignore this, by the way. These are not finished yet. These will be all pretty and bolted, and you're not supposed to see that. But at the top of the actuator, how this works is I found this top here that's actually threaded on the inside. So all you need is this little bolt here. And you essentially just have this little bolt that is going right into the top of the actuator. This makes mounting it really easy. And if you have to, adjust it or remove it for any reason, you just have one bolt at the top.
The other thing that was really difficult about mounting these actuators was if you imagine that, let's say this one is just like 0.5 degrees that way, as it goes up, that only gets worse. So if every single one of these was at a slightly different weird angle, by the time they're fully extended, your roof just would have fallen off and everyone would be dead. So getting these in there was really, really difficult. But as you can see, it worked out pretty well in the long run. But yeah, that was just another part of the design that I wanted to mention that was really hard to throw in there, considering that this wasn't something that we ever thought we were going to do. So to make the actuators as 90 degrees as possible, we're zeroing the level to the floor, and then because the actuators are hanging, we can just move them around until we get it to exactly 90 degrees. And then once we get it there, we'll just mark where the bottom has to mount and boom.
Holy precision, mother. The other thing I want to mention that we thought about that was a very hard thing to plan with this design, and honestly probably the hardest part, was all these actuators could theoretically fail. They should have a lifespan that, you know, is more than the life of the vehicle, all things considered. But in the event that one of these fails, like, it can't be impossible to replace. So, you know, this one is obviously very accessible, as you can see, and we wouldn't have any issues. But some of them are a little more hidden. We kind of had to plan out and make sure we could access these later. Let's say, you know, this one were to fail, we have to actually be able to, you know, get the rod out of the way so we can actually lower the top. So with this design, we would be able to unbolt it right there, remove the bottom, and then we'd be able to remove the entire rod and get it replaced. All of these actuators have what are called a Hall sensor. Essentially what this is it's a feedback sensor inside of the actuator that can tell the controller the position of each of the actuators. The main use for this is it allows you to synchronize all of the actuators, but I think there's an even more important aspect of it that I don't see a lot of people talk about. So, for example, let's say that this actuator failed. You would now have 3 different actuators. Let's say you were lowering the top, for example. You would have 3 actuators that are trying to lower the top while this is essentially a stiff rod. It requires an insane amount of force to overcome these, you know, when they're static like this. So what would happen is you'd have this one, you know, at its height. You would have the other 3 trying to come down, and they would essentially continue to lower until either A, you hopefully notice and stop the switch right away, or B, until you literally rip the roof apart, you know, break one of the actuator mounts. I mean, it's just not good. So the benefit of this is if one of these actuator fails for any reason, the controller will recognize that it's not moving, that it's getting out of sync, and it'll stop entire movement of the PopTop and give us an error so we know what's going wrong. So here is the actual actuator controller itself. This is by a company called Firgelli, and you can see each of these buses is one of the actuators. So this represents the positive wire, the negative wire, and then the 4 wires needed for the feedback sensor. You have a bunch of options here, things you can do, some automation, just general control. You can just kind of do this on like a simple Arduino if you want to do this yourself, but we were kind of just looking for an easy out-of-the-box situation that we didn't have to pay or play with for a while. So as part of the stability, I kind of wanted to show you guys like why it's actually this stable and how these gas struts are working and how you can calculate this yourself. If you imagine, you know, if this strut was facing directly up, it wouldn't do anything to stop movement in this direction, which is essentially the problem with these rods. If you didn't have these struts here, the rods provide no stability and you could just push the top, and I mean, it wouldn't take much force to just completely send it over the edge because they're just really not strong in this direction. So the idea is you have these struts here that are mounted at an angle. Now, when it's mounted at an angle like this, a good amount of the force is actually going up and holding things up. But a lot of the force is also holding or pushing in the horizontal direction. Now you can actually calculate this. It is a little complicated, but there is a bunch of, if you look up like a net force calculator on Google, you'll come across a bunch of calculators, but essentially you insert the strength of your strut, which for us is 80 pounds, and then it can tell you, depending on the angle, how much force is in the lateral direction. And this is essentially what we use to make sure that there was enough stability in this direction, even with the struts at this angle, in order to prevent the top from moving. Now, you can use a weaker strut and try to decrease this angle, which is what we would have done, but based on how tall our top is, this is kind of the longest gas strut we were able to find, so we really didn't have an option to have a longer one, which would be at even more of an angle.
Obviously, we do not have the canvas on right now. We will be putting it on at some point, but for now, it's really nice to be able to get big things in and out through this opening. So until we're pretty wrapped up, we probably won't be putting it on. It does mount on the outside here, as well as all the way up there. So it's a good amount of canvas, and it's just sitting under our bed right now waiting to get on this camper. But in the next video, which we, like Kevin said, we will be releasing it because it's already filmed and ready to go. But we go over this design, we go over the scissor design, we go over different PopTop designs, how we ended up on actually doing a PopTop and not just getting a high roof camper, and all the reasons and things that you should consider when you're looking into getting a camper just like this, or different, really any camper at all. Beyond that, we have so many videos about the interior. We're trying really hard not to show anything in the interior right now. But there are so many really interesting, unique, beautiful parts that we have been filming that we're excited to talk about, excited to show you, and obviously really excited to use once we get on the road. So we are hoping to be a little bit more consistent now, but I promise there will be a video that comes out a week after this one. So stay tuned, and we'll see you next time.